All right, good afternoon, everyone. Today we're going to take a look at a new process that we've been developing for how to create segmented walls. We've had some difficulties with segmented walls in the past where they started out picking which mullion pairs, they got into shop drawings, and then when they get into the actual fabrication part, the the way that the mullions splay and interact give us some challenges. So recently we had a few projects that had segmented mullions on them. One of them was Stevens Creek. We had some challenges with that when we went to determine what all of the fabrication would do. Then when we started on West Edge, we started with a bit of an experiment, and that's how we finished up developing what this new segmented wall process would look like. So this is an example. This is West Edge here on the floor plan. So you can see that there's a lot of different angles on these articulated walls that go in and out. So with that we had a lot of different floor plan geometry that we had to accommodate. So that was one of the factors that we used in order to determine what process we wanted to create. The experiment with West Edge, what we did was Eddie and his team laid out these floor plans, and then the setup team actually did the layouts for all the different degrees of the mullions that would be required. And then we placed them on the floor plans to be able to verify that they would work with our proposed degrees. So that was some of the constructs of how we got to this point. What I have to bring up here, this is the, let me bring it up on this other screen here. Oh, hang on, I can't see it. I've got my other stuff in front of it. One second, I've just got a window in front of here. I can't see my document. Here it is. All right, so we're going to go over this. I want you to feel free to open your mic and ask questions as we start to go through. These are new stages. Some of these items are going to be in flux until we experiment a few times, but this will be the structure of the next time that we start on a building that has a segmented wall, that we would use this as our guideline. So I'll blow this up a little bit so that it's readable for everybody. So part of this is the initial approach is the logic overview. So basically there's three approaches that we could use in order to accommodate the different floor plan angles. So one is to use existing mullion pairs, and that would be if you have an exact match, that would be the primary approach. So if you can get the floor plan geometry to the mullion pairs that are built for that angle, that's perfect. The default approach, if you don't have the ability to use the exact mullion pairs, is that you would rotate the mullion pairs around that 23 gasket. That's the one that's in the middle of the vertical. And then that would splay the mullions, and they would become either wider or narrower in the front or the back. So what that does is it keeps the mullions so that they're pretty close to parallel at the glass pocket. And then you have to miter the horizontal in order to accommodate that. So that miter will not be a bisecting miter of the floor plan. And because of that, when you come out to the face stops have to meet tight at that corner. You don't want to cause those to have a gap by cutting those to a non-bisecting angle. So you have to have two different miter angles, but that would be the default approach. The next one, number three, the non-preferred approach is with the mullions being parallel. And so that can cause some difficulties because the face stop and the miter of the horizontal, causes that face stop or the drive on stop in the back to be slightly out of plane. And then the horizontal is not parallel with the glass pocket of the vertical anymore. And so that can cause some problems with the screw ports in the horizontal body. And it can also cause some problems with how the vertical is notched to sit on the chicken head. So all of those things need to be factored in when you're choosing which approach you want to take. So there's a few pros and cons to each. We talked about that a little bit already, but here's the summary of that.
Hey, Bill, before we jump into the pros and cons, I guess the other method, and this is dealt with before we even get to it, but it's just redesigning, like coming up with new dies for each one of the corners, right? So,
That's correct.
so do we know when, like how they make that decision? Like when is it that they decide that it's worth doing that versus kind of like on Central and Wolf, where every one of those corner conditions had that, versus another job where we're, trying to make something we already have work.
Yes. Yeah, we'll cover that. That's in the next section.
Okay, cool. Thanks.
So the mullion, the method one is if the mullions are parallel to each other and they match the floor plan exactly. So that's the preferred approach because it's the easiest to build. Everything's exact. All of your alignments work by default. And then here that speaks to what Chris was asking too, is you do have the additional time of and cost of building new dies if you don't have those occurring that you can choose from to use on your project. The method two, rotating the mullions around the gasket, that keeps the verticals closer to align with the horizontal mullions, and the horizontal body miter will be based on the rotation of the mullion, so it won't be a bisecting angle, but the face stop must be a bisecting angle still when they come together tight at the corner. So the rotation of the mullions then might have an effect on how the glass and the gasket work. So you have to be cautious if you're using the rotating the mullions so that you don't rotate them so much that your gaskets don't close properly in the middle of the vertical. And then method three, with the mullions being parallel, that allows to do a simple bisecting angle of the floor plan geometry in order to cut it, but it requires extra layout on the fabs so that the screw ports and the notches are all set up properly. And it might cause the back of the pocket and the back of the vert to misalign with the horizontal body. So those are some of the pros and cons. Now, we're going to move on to this next section, which is the base mullion pair logic. So the vertical mullion pairs are based on the floor plans of segmented walls or corners, and that's especially the case like on that floor plan that I had brought up for West Edge. So if your base is the exact floor plan angle, that's perfect, but you can use this range of plus or minus 1 degree for the base mullion. That's the jumpstart guideline that they would be able to use. If it gets beyond that 1 degree range, that's when they're going to look into designing and building new dies for that new floor plan angle. Okay, so there's a couple of examples of what the degrees might be, but in general, the approach is that you can rotate that around that 23 gasket up to the 1 degree. So this is where we get into that answer for Chris's question, is the segmented wall process steps. So pre-bid, this is where Jumpstart uses their process to decide if we need to build new dies. So we haven't fleshed out the steps for the specific steps for Jumpstart. We'll need them to help us develop kind of the step-by-step instructions for that if we want to incorporate it into the Swiss. But this is the base guideline for that part of the aspect of the project, is they'll use this, so they're going to decide. So we have a new process that we're introducing here using the Jumpstart to Drafting Trello board. And let me see if I can bring that board up. So in the Jumpstart to drafting handoff board, the Jumpstart lane has the checklist items, and Jumpstart goes through and takes care of all these things on each project as they go through this. That's actually this template card here. Then we have a couple of triggers that we look at our Tuesday meeting each week. And the first one is, are there any dies that are being added or modified? That way the team knows that we've got to work on something there. But here's the new card. Are there any projects that just kicked off that require the X team? And that was just a name I put in my document, but it seems to be sticking. So basically the X team, we'll get into the detail of that a little bit more in a minute, but basically it's the team that was going to review the vertical angularity, and that will help to decide what has to happen. Do we need to build new dies? Can we use that plus or minus 1 degree range? How many variables are there that are going to affect our decision if we need to make new shapes or if we can use what we have, and if we're going to use them parallel or if we're going to rotate them. Okay, so the Jumpstart pre-bid process will determine what mullions are available from the library, and then they'll analyze those mullion pairs using that plus or minus 1 degree base logic to see how many of those could be reused. Part of that analysis is going to be drawing in the bond widths, making sure that the glass bites are working properly, any other factors that might have an effect on our decision on if we need to make new dies or not. And here's part of the key to that is pre-bid is the only time that we can get money for new dies. So we don't want to start designing dies as after we're doing the real floor plan layouts and then determine that we prefer to have a slightly different mullion. That needs to happen pre-bid through the Jumpstart process. So part of that analysis then would be they would decide which approach, if they would get rotated around the axis or parallel to each other. And we intentionally highlighted these in yellow and red as the preferred method and the not preferred method. Once the analysis is done, then Jumpstart would design a new and build the new dies as they picked which ones needed that new die shape. Okay, so again, this is all pre-bid. This is preliminary stuff from the Jumpstart process. So any comments or feedback on that part so far?
So would Jumpstart ever use the parallel to each other method if that's not their preferred?
Yeah, we did that on West Edge. That was a choice that was made, but it's not the preferred method. So that would be kind of the if necessary, but try to stay away from it if possible.
Well, can you explain that? I'm not sure I understand what parallel means.
So let me give you the CAD examples. So on West Edge, these mullion pairs here, this is a 120 degree corner. This is a 120 degree floor plan. These mullions are parallel to each other. So if you measured across here, this is going to be that consistent 2 3/4 or 2 1/2, whatever this mullion pair is, from the front to the back. So in our cases like this mullion pair was built for 114 degrees. Well, these were used parallel to each other. So these mullions are still setting together at 114 degrees, but the floor plan geometry is only 112.8. So in order to make that work, we bisected that angle to make it 56.4. And you can see what happens is this is the back of the vert, but this is the drive on stop. So they're not in the same plane as each other. When you look at the glass pocket, for example, the glass pocket is here it's out of plane with the vertical mullion. It's only connected right here at that intersecting point. The preferred method is similar to some of the layouts we did on South Main, where if we had this 114-degree mullion pair, but we needed it to work for this 112.8, we would have laid out the 112.8 on the floor plan layout and then rotated these mullions so that they kept the same, so that they would stay parallel to the glass pocket. So the face of this part of the mullion would have been parallel, and they would have been splayed so that if it was 2 3/4 in the front, it might have been a 16th smaller than that in the back as far as the mullion's closing up. And that's part of the analysis that has to happen during this layout stage, because if you try to pull those together too much, the backs of these mullions might get too close together and these legs may not work properly anymore. So that's why we need to do this analysis as part of that, why that jumpstart to drafting card got determined, so that we can help determine these areas if there's some that are close, but we want to check that range to make sure if they're going to work or not.
So when you rotate around the 23 gasket, your front dimension, your back dimension would not be the same. Is that right?
Correct. That's
And
correct.
then if the 1 degree rotation isn't enough, then in addition to that, you could also bisect and miter.
That was not an option that we talked about. So
Okay.
That would be beyond the guidelines of what our normal practice should be. So if that was a choice that we had to make, that's one that we would have to do the careful layouts and decide together before we launched it into like building families, for example.
Okay.
Okay, so really all of this analysis should be happening in this stage so that it's right in between the pre-bid process and then the post-bid once you've made those decisions. So if you're at this point in your pre-bid and you're trying to make those determinations and you've got one that's, oh, this one's pretty close, that needs to go back to that jumpstart card where it says we need the X team to help do some analysis here. Okay. So then let's move on to post-bid. So post-bid is, that'll be after the decision on which dies will be used. So at that point, jumpstart or drafting, possibly, this is maybe during the dimensional approval process. This part we haven't practiced yet, so we need to incorporate this once we get the next project that has this. But basically, this is similar to what Eddie and his team did for West Edge, is creating the floor plan layout. And here's the key to that stage of this process, is trying to minimize the angularity on the floor plan. So on the West Edge, we had a lot of different degrees that were a 0.2 and a 0.6 and a 0.85 and so many variables. And in some cases, we had one mullion pair and we used it for 4 different angles. So that created a lot of extra work in order to make all those mullion pairs actually work together. So if possible, when we're doing that floor plan layout, if it's part of the dimensional approval, that's fine. We want to work with the customer as much as we can to try to minimize how many different angles that we're actually going to be using in order to get our floors to close. And then here's another factor, the number 14, is that the floor plan layouts should be made to a 1/2 degree tolerance. We should try to avoid these small fractional degrees for floor plan layouts whenever possible. So in a lot of cases, if we laid it out properly and we had those conversations with the contractor, we could probably avoid using these small fractions and pick the ½ degree range. That's really the construction tolerance that we want to work within anyway. So when we're laying them out to very fine degrees from that, then it just puts a lot of extra burden through the engineering process in order to try to make that work. So if we can avoid those small fractional degrees, and especially like the small differences from mullion pair to mullion pair, then the layouts should be easier.
So Bill,
Yeah.
are we actually then going to the customer and asking for them to revise their building layout so that the angular dimensions of a corner are a more rounded number? Is that what you're saying?
In some cases, yes, definitely.
Okay.
Yeah. So after, as we continue on this, once the floor plans are established here, then the X team would take the dies that are available for the project, both those that we decided we are going to build. So these would be new die shapes. This potentially could just be the profiles of these. We don't need families at this point. We just need the shapes of the mullions. And then we'd also take any of the dies that are coming in from the library, and potentially that would be that ±1 degree range. And then we would create the layouts that we would superimpose on the floor plans. So the examples of that are what we see on these sketches. The floor plan itself, so let's say we built this floor plan and we've got this layout. We establish where the glass pocket is, where the face of the system and the back of the mullions are. Then we do the layouts on these type of layouts. This is the class that I gave 3 or 4 weeks ago about how we were doing these layouts. So then we would take these layouts and place them on the floor plan. And as we were doing that, if we had some, in this case, we got a very kind of an unusual degree, but as we place this, we could see what did we build this to? We built it to a 133.8 with a 66.9 degree miter. And if we saw that there was a range that we wanted to be able to use for fabrication. So for example, if we did have some angles that were close, we would pick kind of an in-between range of a little bit that way and a little bit that way. And then we would place them on the floor plan, but then actually rotate the mullions so that they were following the floor plan exactly. So in this case, it varies a little bit from the floor plan. We did a 133.8. This was a 133.76. So that's just rounding. So basically we built it to this degree. But if we place this on one that was also a 132, if we decided that we could make that work, we would actually have to rotate this in order to fall on that floor plan in order to make sure that it was still working. So the example that we used, this one was the mullion pairs were built as a 50 degree. So at first we built this as 50 degrees. But when we placed it on here, because this corner is so sharp, we've got such a long surface for this miter that when we rotated it around to match the 50.2 degrees on the floor plan, even though we had originally built this to 50 degrees, it didn't work. These parts of the mullions here were so far out that they would not have closed properly. So at that point, we made the decision to build this to the 50.2 degrees, matching what's happening on the floor plan, even though it changed our miter by that 1/10 of a degree. A 1/10 of a degree doesn't sound like much, but when you do this sharp of an angle, it made a difference on making the mullion pairs work or not work. So we had to do it. So that's kind of that part of the analysis that we're talking about here, using those dies. Okay, so part of that then is we're placing them where they're going to belong and then making sure that there's no difficulties. So the next step then is determining all of the corners, splayed mullions, etc., that are affected by the floor plan, and then identifying those, basically labeling what each of those mullion pairs would be on the floor plan. So we can see on this spot, we can use the exact mullion pair. On this one, we have to rotate that around the axis by half a degree. So getting all that stuff labeled on the floor plan so we know that's part of the plan of knowing which mullions are going to be used where. With that in mind, the next step would be if we need to do a modified mullions approach. So that would be that preferred method 2 or preferred or not preferred method 3 if we had to. But basically showing each of those areas of how that segmented mullion pair is going to work. Then it would analyze that range of rotation that can be used. We talked about that already. Determining what that range of tolerance could be used. We talked about that a little bit too, where, you know, if you have a 158-degree mullion pair, for example, but you've got a floor plan with 158.5 degrees, but you've also got a 157.05 and a 157.23, then we would do that analysis. We may decide to do 2 different versions where we have a 157.1 degree that we use, and then for the other one, a 158 even. So if that's the case, we would need to do profile modifiers. That's where we get into step 21. So once we get to that level, the layout ranges that we're using, if we pick that 2 mullion pairs, 1 mullion pair accommodates 3 different floor plans with only 2 different rotations, then we only need 2 profile modifiers. And then at that point, we would label which profile modifier is used for that mullion pair. So part of that floor plan is we're going to say we're using the 158.5 degree mullion, but we're using the profile modifier to use it as a 158. In this other condition, we're using that same mullion pair, but we're using the profile modifier to make it the 157.1. That way we know exactly where the profile modifiers need to be used on the floor plans. And then that can be used as we're doing the shop drawing part and putting the profile modifiers in so that it turns on the data correctly in the takeoff program. So once we get beyond that, when we move into that detail level of how all of the parts and pieces work with the face of the system, the glass pocket, the back of the system, etc. So this just goes into a bunch of detail on that. One of the things that we had in mind, though, is that as we're doing the floor plan layout, we can actually place all of the key measurements right on the floor plan. So the example again on this one for West Edge is once we place these mullion pairs in here, we had the deductions for each of the extrusions, and those are all set up here so that you can see the shapes of the parts. And then the different combinations of those, this was the left end, this inside corner was the right end. Then we just placed the actual sizes. These are the cut sizes for all those individual parts. So we would still use our layouts and our CAD drawings in order to check the fab tickets, but we can check our sizes right off the floor plan. So that's one of the concepts that we wanted to approach as well. So one of the keys to this is that once we determine what all of these layouts are, we know where the mullion pairs are going to be used. We know which ones need profile modifiers. So when you go to build the shop drawings themselves, then the next stage of that is the family planning process. So we're going to review that next. So any questions before we jump into the family planning part? Okay. So next, the family setup team would develop the new families from the profile package and that X-team layout as necessary. So these are all in blue because these are just preliminary thoughts right now. We need to practice these and then fine tune these a little bit to see how this might work, but this is the proposed version. So families for the shop drawing process are built with these following guidelines. For conditions that use the mullions that only match the floor plan angles exactly, you would build the family for the mullions as they're designed. So great examples of that are just standard 90-degree and 135-degree corners. You just build those mullions, that's your family. The layouts work by default, no extra work's required there. The next thought then is for conditions that use mullions to splay that create only one defined segment, so then you would build that family to the defined segment. So here's a prime example of that. You have a segmented wall and your normal vertical mullions are just straight mullions. They're parallel with each other and you use that on all the straight walls. Well, that's fine. But if you have a segmented wall and you have a 179.5-degree segment, you don't want to rely on that straight family to try to accommodate that half-degree segmented wall. So at that condition, you would build a family for the 179.5-degree segmented vertical mullions, even though it's the same typical verticals that you're using on the straight wall. But having a family built for that little half degree at the segment makes sense in that condition. On C, this one is one that's going to be up for debate, which is why I highlighted it in green. But a couple of different versions of this could happen. For conditions that use the mullions that splay to create multiple defined segments, so that example we just gave of the 158.5-degree mullion used for 158, and then, oh, it's the 158 mullion used at 158.5 and 157.1. So you could build the most common one. So for example, you could build the 158.5. You could build a family to that because it's going to be a profile modifier anyway. Or the alternate idea is if you have that kind of an angle that you build only to that, the way that the mullions were designed. So if you build it to 158 degrees, even if you don't have 158 degrees on your project, then you would have only one family, and that family, if we built out the data for it, could go on the server because that's a default data, and then the profile modifier database would have these different examples. So it would have the 158.5 and the 157.1. And this one, again, needs some discussion before we make that decision. But that'll be part of the first experiments as we go through these to help decide what that looks like. The key point here is that when you're building the families, you don't need to build a family or have a shop drawing detail for every single different layout that we did. So on West Edge, we wound up with 40 or more layouts that we had to do in order to accommodate all the different ranges of mullion pairs and different degrees that they covered. But we didn't have 40 individual shop drawing pages that accommodated that. And realistically, we don't need them because the layout has to be so much more precise than what you see in just the shop drawing detail anyway. The Revit family won't show the real floor plan details, so you can't do like a live cut through a Revit family and see what your floor plan is supposed to be doing. It has to be done by layout. So with that in mind, we would next move into the shop drawing process. So the shop drawing details use the families as built in order to create the details. And again, it's got similar guidelines for conditions that use the mullions that only match the floor plan exactly. Then you build the details as the mullions are designed. For these conditions that you have that one defined segment, then you would build the detail to that 179.5 degree is the example that I'm giving here. Okay. So you would list that mullion pair. It's the same as a typical vertical, but you'd also list out the floor plan angles being used on the shop drawing detail. So for the example, you've got a 180-degree mullion, but you're using it as a 179.5 as a typical segment. So you can put that note on the shop drawing, and that'll become a little bit more clear on this last item. So if you use that condition to make the mullion splay across multiple defined segments, you're going to build the detail for the most commonly defined segment in that range. So in this case, you're going to build the 158-degree mullion pair. So that's the one that's in the shop drawing detail. But then you're going to identify on that detail that you're using it for 158.5 at, say, the third and the fourth floor, but you're using it at this 157.1 at the fifth floor. So we can tell that there's variables being used by seeing the shop drawings, but the floor plan layouts themselves are actually accommodating what the different ranges are and the specific angles used at different points. And again, that layout we're proposing to do much early in the process, way before shop drawings even start. So those are the base guidelines. Now, as we were doing our discussion on this on Friday, we came up with, let me bring that other document up so I can see it here. So kind of the summary of what this new process would look like. So pre-bid, Jumpstart should be figuring out the mullion pairs, drawing the bond widths, etc., to see if we need any new dies, because pre-bid's the only time we can get money for it. Then post-bid, we need to do a floor plan layout and try to minimize the angularity on the floor plan as much as possible with discussions with the customer. Then the X team takes the dies for the project, both those that we decided to build and those that came in from the library with that plus or minus 1 degree range. And we do the layouts and superimpose them on the floor plan. Then the families and the shop drawing details do not need every condition detailed. The X team will decide on which mullions will be used where, which can be used as server dies using that 1 degree range of splay, or just being able to work at that floor plan geometry to accommodate slightly different floor plan geometries with more than, with one mullion pair spanning maybe sometimes plus 1 degree, sometimes minus 1 degree. And so this whole step is going to be a check for that mullion pairs logic of what was picked for the project to place them where they need to go and make sure that they're going to work without running into any trouble areas. So by doing this layout in that early stage, we can identify and eliminate the defects that might occur that we've sometimes seen in the downstream processes, so that now the next process that flows from creating the floor plan and the geometry actually has the stages and the steps built in so that it should work without having a bunch of challenges with the geometry and the mullion pairs that we decided to use. So, whew, that's a lot. All right, so that's pretty much the extent of the new concepts, but I want to just open it up for discussion a little bit because, you know, a lot of you guys haven't seen this yet. It's something some of us have been working on for a while, and we've got it to the stage where we're starting to introduce it, but it's still fresh. So you might have some additional questions that we can review at this time.
Well, I just have a comment that this is great that you guys are doing this. I remember back when we were working through 700 Santana, and Chris was doing units, and he started taking the units in plan and putting them on the floor plan on the key sheets, and he was finding out, wait a minute, this isn't really adding up. We have an issue here. And it's because the shop drawings were drawn with the dim points at the face of a system in a concave wall. But yet, when we rotate those verticals, suddenly it's like we're transferring that point to be, instead of at the face of the system, or maybe it's even 1 inch out from that face of the system, now suddenly our hinge point is back at that 23 gasket. And that math caused us to have some problems. So we needed to go back and do some rework. And so thank God Chris was seeing that and doing what he was doing, and it helped us on that project. But this will help prevent that sort of thing from happening on a lot of projects down the road. So thanks for doing that.
Yeah, that definitely. It was too bad that we had to find out so late on Santana Row. We had to resize a lot of the units because the 23 gasket wasn't it wasn't being engaged. But doing it early at this stage is gonna avoid all that work.
Yep, it's definitely that source management that we're trying to incorporate here. It's just that we never really had a process for it, and it does require that the takeoff team and the setup team gets involved earlier than we ever have before. But we did that with West Edge to great results. Yana sent us a note that when she ran out the material takeoff, she had no markups. So that was pretty spectacular. All right. Any other notes or comments, questions on the concepts?
I think my biggest takeaway from this is the degrees that we can try to push back on. Like, we've seen so many different degrees on West Edge where it's to the 100th degree decimal place, 100th decimal place of a degree, 50.19. So it's like, wait, if we can minimize that and round it to the nearest 0.5 degree, we would have 50 or 50.5. So I don't think we knew about that. We could push back on these degrees and maybe be like, well, can we just round them to a better degree that would accommodate for our end, right? Yeah. This rounding, if it happens, it'll definitely eliminate a lot of profile modifiers, right? And we would only see degrees with either a whole number or a 0.5 as a decimal, and none of these other ones, right?
Yeah, we, as a side thing, when I started my career, I was in skylights, and we were doing a big barrel vault skylight, which is kind of, if you picture a barrel laying on its side, and you cut it right through the middle and set that on top, so you have a skylight that's like this big arched dome. And each one of those horizontals was being mitered to create this sort of truss system that goes across. And the person that was doing the fabs initially had laid out all of those miters to the first place after the decimal. And during this process, we came up with going 5 places past the decimal. And if the shop had cut them to just the first place after the decimal, versus doing it all the way out to 5 places past, in the end, that changed us hitting that other side. There was a 3-inch difference just by each end of a horizontal just being mitered a sliver of a degree wrong. Yep. But these things are, depending on the size of the segmented area, it really adds up. And because it's angular, it really can cause some problems. So, yeah.
All right, very good. One last opportunity for commentary.
So the floor plan, I thought the floor plan wasn't, with the degrees, wasn't available until even during pre-bid.
So pre-bid, the floor plan may not be available. So Jumpstart has to do some back and forth with how do they choose which mullion pairs that they're going to need. But then right after that is when we want to start doing, right after that decision, we want to start working on the floor plans. as soon as possible so we can start doing these layouts.
Is that
So-
from the Revit model that the architect provides, like right after post bid?
Probably have to get a drafter to weigh in on that. And this process, we haven't qualified yet exactly who's doing these, but potentially it could be the drafting stage where they're doing the floor plan layouts. The first thing that should happen as soon as they have that floor plan laid out is we start analyzing the mullion pairs and placing them on there. Because at this point, it's still very early in the drafting stage. We can analyze this to see if there's any trouble areas that we may need to just investigate this. We haven't created a feedback loop to ask Jumpstart to make new dies if we find something at that level, but that's a discussion that we would want to have. And this is still very early in the process. All right.
Maybe I have one question, Bill. When you rotate that the verticals or corner verticals, that would change the glass bite. Are we putting that now on the unit?
Yes. Yeah, that's all part of the profile modifiers if necessary. So if you can build it to the exact angle, then you don't need a profile modifier. Your glass bite works as built. But part of the layouts that we were doing, we'll just use West Edge because I have all those open. We incorporated the glass bites from the dim point to the glass. We incorporated that math in any of the layouts that we needed a profile modifier. We incorporated it into there. So the glass size is definitely taken into account in our analysis.
Yeah, so we on West Edge, if the corner or the vertical needed a profile modifier, we manually adjusted the glass in the model so that when it came out, you didn't have to manually change the bytes. And it would take the unit's number would read the bytes also.
So for the shop use, we should put the bytes which side that we have, like what we did in Stevens Creek. I followed the modifier, but then it add up the opening of the glass into like more than 3/4. So I end up adjusting how much rotated in the left side vertical, like the male, and then the female, I have to rotate that one too. So the glass will change the bite, but because the glass will stick into the 3/4 joint from dimension point, like trade. So there were times that we're gonna adjust those, and we start putting those bite from the lower unit column wise out all the way to the top.
Well, I think the difference between Stevens Creek and West Edge was that when we started adding the profile modifiers on Stevens Creek, the glass was already ordered. On West Edge, when we changed the bytes in the Revit model, the glass wasn't ordered yet. So we had that freedom to make that adjustments and see if there was enough bite on the glass, and without changing the mullions in the units so much.
Yeah, but the bite of the glass should be sizes based on the floor plan dimension point to dimension point, not based
Correct.
on the verticals. So it is okay to order the glass before you size the unit, because the unit is you size the frame based on the unit per rotation, but the glass is everything is per floor plan, dimension point to dimension point. So there would be no problem with the glass, but you just adjusted how you adjust the frame.
That's correct. We have whatever the glass adjustment needs to be made is built into how the profile modifier is working. So all of those are a byproduct of doing this source management and doing this process early. So you can see there's a lot of benefits to this. Okay, excellent. Good points, everyone. Any additional comments or discussion?
It was actually funny about West Page today. Today and yesterday, I was getting calls from PM, and he's actually checking the glass. And he was like concerned a couple places because he was following the detail, and detail was saying varieties.
Sure.
And when I was going on a unit, my glass kind of looked good in the relationship with that particular unit, with that particular twist on that unit. And I kind of told him, like, you know, you might be seeing this detail, but it's not like you have to take in consideration that it might be slightly twisted. You need to look in the floor plan.
You might need to point him to our sketch folder that has all these layouts in it.
It's brutal.
All right. Well, stop share there. Okay, well, thanks everybody for listening and paying attention. And just keep in mind, as this comes up, we will need to get engaged with this. So we've done some examples on some of the previous projects. We have some methods that we can use. So if you get recruited to do some of these layouts, then we'll do some Gemba sessions and work on the mechanics of it as well. This is kind of the overview of the whole process, but we've definitely worked on some of the mechanics of how to do the actual step-by-step for building the segmented part, placing them on the floor plan, rotating them around, making sure they work. So we've got all of those concepts already developed. So
I enjoyed a lot doing layouts like this when it comes to multiple layout, and I would like to be taken in consideration when it comes to, you know, to call somebody to cooperate into a project that is going to require this.
Yep. All right. Well, thanks everybody.
Thank you, Bill. Thank you, guys.
Thanks,
you,
Bill.
Thank you.
Thank you, Bill.